In this video, I will show an example of classic, what I like to call loop integral. Let's start by integrating it by parts, and the choice of u is e to the x over 2. Therefore, dv will be sine 5x dx. Du will be 1/2 e to the x over 2 dx, and v will be negative 1/5 cosine 5x. So the result of the integration by parts will be negative 1/5 e to the x over 2 cosine 5x plus 1/10 integral e to the x over 2 cosine 5x dx. And we're going to set up another integration by parts. The choice of u is the same as before, so u equals x over 2. Therefore, du will be 1/2 e to the x over 2 dx. dv is cosine 5x dx, thus v is equal to 1/5 sine of 5x. And let's write the result of the second integration by parts. So first let's copy this expression as it wasn't affected by the integration by parts, and we'll write the integration by parts in brackets over here. So uv will be 1/5 of e to the x over 2 sine 5x minus integral v du will be minus 1/10 integral e to the x over 2 sine 5x dx. And what we notice here is that we ended up with the same integral that we started with. And the idea is to label this integral with some letter I. And let's write down what we know about I. We know that I is equal to negative 1/5 e to the x over 2 cosine 5x plus, and I'm going to distribute 1/10, so 1/50 e to the x over 2 sine 5x minus 1/100, and this is the same integral, so we call it I. Now we can add 100th I to both sides, so we have 101 I over 100 on the left hand side equals to this. So I'll just copy it. And now the last thing to do is to multiply both sides by 100 over 101 to isolate y. So I'm just going to do it like this. And remove this. So at the end we add plus c, and this is our final answer. That can be simplified slightly by distributing 100 over 101 over, so we get negative 20 over 101 e to the x over 2 cosine 5x plus 2 over 101 e to the x over 2 sine 5x, and of course there's plus c at the end.